Okay, welcome to today's class. We're going to be working today and tomorrow on section 1.5, which is dealing with equations. We'll be looking at lots of different equations. There's a lot in this section, so we'll be spending 2 days on it, and then we will stop after that and have our first test coming up that will cover sections 1 through 5. So in this section, we'll look at linear and quadratic equations as well as rational equations, equations with radicals, and absolute value equations. So lots of different ones to look at here. Okay, I have a startup that is going to review your rational expressions, simplifying those. So if you'll take just a minute and pause this video and try the startup, and then advance and see what your actual answers should be. Okay, for the first one here, if we look at this one, you can see that we have our denominators. We've got x plus 1 squared and x plus 1. So when we look at this, our denominator needs to be an x plus 1, and it needs to be to its highest power present. So it would be to the second power. So that's why our least common denominator is going to be x plus 1 to the second power. So to get a common denominator, if that is our least common denominator here, this one already has what it needs. So this one needs to be multiplied by the x plus 1s, and we do x plus 1 over x plus 1. Okay, when we do that, we then end up with the same denominators or equivalent denominators. So we can combine these together. So we'll write the denominator one time, and then we'll have our numerator here of what's left. We'll simplify by distributing the two and then combine like terms, and we have this as our answer. On the next one here, we have a complex fraction or compound fraction. So our least common denominator for just the numerator part, so we're just going to work on the numerator first, would be x minus 1 and x plus 3. So when we come down here, here's the problem part, and we decided that our least common denominator needs to be x minus 1 and x plus 3. So this one has the x minus 1, so we're going to multiply top and bottom by x plus 3. This one has the x plus 3, so we're going to multiply the top and the bottom by x minus 1, so that we end up with the denominator that we need that's the same for both. Okay, so we'll keep this x plus 1 still in the denominator, so it was here and it's staying here. We're not doing anything with it right now. Okay, these we're going to combine together, so we put them together with a common denominator. We'll add this numerator and this numerator together. And then when we combine like terms, we end up with 2x plus 2 over this common denominator, and then it's still all over x plus 1. So here we have basically a fraction. So this is one fraction over another fraction. And if you remember, when we have a fraction divided by a fraction, we do keep, change, and flip. Okay, so we're going to keep the first one the same, change it to multiplication, flip the second one. So we're flipping this one. And then from here, once we have it to the point that we are multiplying, we can then cancel these like factors. Now, one thing you can't, if you have an addition or a subtraction symbol, you can't cancel like from here to here or here to here. You can't do top to bottom if you have a plus or a minus. It's only if you have this multiplication that you can go in and cancel like factors. Okay, so moving on to today's lecture, starting about equations. Equations, we actually are going to be solving these for solutions or roots. You may have also heard these referred to as zeros, because on a graph, these are the places it touches the x-axis. That's going to be our solutions. So these are the values of the unknown that make the equation true. Okay, so the first one we want to look at is linear equations. Linear equations have one variable, and it's of this form: ax plus b equals 0, and that's going to be our linear equation. So x has to be to the first power to be a linear equation. Okay, so if we look at these, all of these examples here, we have our x and we have it to the first power. When we look at these would all be nonlinear equations because x is to a power other than 1. So this would be to the second power. We know that the square root is the same thing as to the 1/2 power. So that would be the reason that the square root is not linear. And then here we have x in the denominator. We know that's the same thing as x to the negative 1, and that's the reason that it's not linear for this one. Okay, we want to look at solving some equations. I'm going to start out with just some very basic ones, and then we'll progress from here. This one, you want to get x by itself. So what I'm going to do is I'm going to actually add x to both sides, because I really don't like to have a negative in front of my variable. So those are going to cancel, and I'm going to have 3 equals 2x. So I'll add x and x together. And then I'm going to divide away the 2, and I'm going to get x equals 3 halves. So we want to make sure that you can solve these simple equations. Hopefully this is very much a review for you. This one, we again want to combine our like terms together and move our x to one side and the constants to the other side. So I'm going to start by subtracting 3x. That'll give me 4x minus 4 equals 8. And then I'm going to add 4 to both sides. I'll get 4x equals 12. Divide by 4. And x is going to be 3. One thing that I didn't mention on this first one is you can always take these and plug them back in and it should work. So 7 times 3 minus 4 is going to equal 3 times 3 plus 8. Because this would be 21 minus 4 is going to give us 17. And this one's going to be 9 plus 8 is also going to be 17. So you should be able to plug your answer back in and check it. Here's a couple others that we have. If we have a number out in front, we're going to distribute. So 2 minus 2x equals 3 plus, we're distributing, so 3 plus 6x plus 5. Combine these together over here, the like terms, before we try to do anything else. I'm going to add 2x to both sides. So I'll have 8x plus 8 equals 2. So I'll subtract 8. So I'm going to get negative 6 equals 8x. I want x completely by itself, so I'll divide away the 8. And so I'm going to get x equals negative 6/8, which is the same thing as negative 3/4. Occasionally you have problems like this where you have a fraction equal to a fraction. In a case like this, the process of cross multiplying is going to be helpful, and you need to make sure that you have the equals in between to be able to do that. So when we cross multiply, we're going to multiply these two together, and then we're going to multiply these two together and set them equal to each other. So we'll have 5 times 2x minus 1, and we're going to set that equal to 4 times x plus 2. So we'll distribute here and have 10x minus 5 equals 4x plus 8. Subtract 4x. We'll have 6x minus 5 equals 8. So we're going to add 5. So 6x equals 13. So x is going to be 13/6. One thing about this, we're all at different stages as far as being able to work out the math here. So, if you're able to combine and skip some steps, that's fine. Just be really careful that you are showing a sufficient amount of work for that. Okay, one thing with the equations is, and sometimes I don't do this section, but I do think it's valuable for you to know how to solve an equation, especially in like your science classes, for a particular variable. So if we solve this for the variable m here, I need to get this m by itself, so I need to move everything else away from it. So basically, we're going to just do the opposite function with these. So if I'm going to get rid of r squared is being divided into m. So to cancel division, I'm going to multiply by that to cancel it. So I've got r squared f equals g little m capital M. And now all this is multiplied to the m, so I'll cancel that by dividing. So I've got m equals r squared f over g and lowercase m. Okay, here's one for you to practice. So if you would like to practice this, pause it, and then you can see how to work this. Okay, this one we're solving for r. So this is the one that I want to have by itself. So I'm going to get rid of the n and the t. They're multiplied. So I'm just going to do that by division. So I'm going to have r equals pv over nt. So hopefully you got that correct. Okay, the majority of our class today we're going to spend on solving quadratic equations. A quadratic equation is going to have this square term in it. So linear only had x to the first power. Quadratic equations have x to the second power. So these were examples of linear equations, where these are examples of quadratic equations. Okay, so in solving quadratics, we have basically 4 different ways we're going to approach it. First of all, if you can factor it and factor it easily, then that's going to be your easiest way. The second one is occasionally you get lucky and you have quadratics that really don't have a just an x term, so you're able to separate your constants and your square terms and simplify it from there, and that's not too difficult. So we'll look at a couple examples of that. We'll work with completing the square, which is not most people's first choice in doing that, but it's a technique that's important as we start doing some other techniques along the way. So we are going to go ahead and cover completing the square. And then probably most people's favorite and the one that's going to work all the time is your quadratic formula. Okay, if we want to solve quadratic equations by factoring, you have to use what's called the zero product property. And the zero product property basically says if two things are multiplied together and they equal 0, then that can only happen if either A is 0 or B is 0. One or the other of these have to be 0 for the product of the two to be 0. So the steps that we're going to go through is, first of all, it has to be set equal to 0. So if you're asked to solve an equation and it's quadratic and it's not set equal to 0, the first thing you want to do is set it equal to 0. Second, factor if it's factorable. Remember, not everything factors. So if it isn't factorable, then you'll have to use some of the other techniques that we'll be talking about later. Set each factor equal to 0 and then solve. So here we have x squared plus 5x minus 6 equals 0. This one's already set equal to 0. So we want to try factoring this. So we need the factors of 6 that subtract give us 5. So that would be 6 and 1, and we would need the 6 to be positive, give us a positive 5. So we end up with these two factors. So this is like the A, and this is the B in the zero product property. So these two equal 0 if and only if one of these are equal to 0. Okay, so we'll set x plus 6 equal to 0, and we'll set x minus 1 equal to 0, and we get negative 6 and positive 1 as our solutions here. Okay, on these problems, we're also going to be solving by factoring. If we look at this first one here, if you recall, on any quadratic, you're going to get this set equal to 0, so we're going to pull the 24 over. In doing that, we have to figure out what multiplies to give us 24 and subtracts to give us 5. So that's going to be 8 and 3. We need the 8 to be positive and the 3 to be negative. So we'll have x minus 3 equals 0 and x plus 8 equals 0. So x is going to be 3 and x is going to be negative 8. Okay, moving on down here, we've got this one for us to practice with. It's already equal to 0, so we need the factors of 12 that are going to subtract to give us 1. So that would be 4 and 3. And we need the middle term to be positive. Okay, so we'll set each of these equal to 0. So x would be negative 4 and x is going to be positive 3. Okay, sometimes we get lucky and we have these simple quadratic equations. When you have something of the form x squared equals a constant, then you can simply just take the square root of both sides and you'll get x equals, and this is the place that you have to be careful. When you take the square root of 9, a lot of people are going to say 3 and think they're finished. It's actually plus or minus 3. When you take the square root of a number, you have to remember to put the plus or minus in front of it. And so you'll have both 3 and negative 3, because if you think about it, if I square 3, I'm going to get 9, but also if I square negative 3, I'm also going to get 9. So I need to get both of these answers here. On this one, if we take this square root of both sides, I'm going to get x equals plus or minus the square root of 15. If there were anything I could take out from underneath this radical, I would need to do that. But the factors of 15 are 5 and 3, so I don't have anything to take out from underneath that radical. Okay, here I've got one. This is not exactly in quite as simple a form, but I do have something squared equal to a constant. So if I take the square root of both sides here, I'm going to have x minus 4 equals plus or minus the square root of 5. So always put your plus or minus here. And then I just need to solve this for x. So I'm going to move this over by adding 4 to both sides. So when I add 4, I'm going to have 4 plus or minus the square root of 5. So my answer is not going to look very nice and neat, but this is what it should be here. On this one, kind of the same situation. If we take the square root of both sides, I'm going to be left with the square and the square root cancel each other, just as it did up here. So we're going to be left with 2x minus 5, and that's going to be equal to plus or minus the square root of 81 is 9. And then I have to solve this. So I'll have 2x equals 5 plus or minus 9, just moving the 5 over, and then divide by 2. So x is 5 plus or minus 9 over 2. I do not want you to leave it in this form because this could be simplified. So if I do 5 plus 9, that's going to be 14 over 2. And if I do 5 minus 9, that'll be negative 4 over 2. So we have 7 and negative 2 as our answers on that. Okay, the next technique that we're going to use for solving quadratic equations is completing the square. And I'll go ahead and tell you this is not going to be anybody's favorite choice for solving a quadratic equation. It's more a technique that's important for us to learn for later purposes. And so with completing the square, what we're going to do is we're going to look at taking a quadratic and making it into a perfect square so that it can be factored. And you just need to keep in mind that the part that you're going to add to each side, and you'll understand later as we go on, is this b over 2 squared. Okay, remember that a quadratic is the form ax squared plus bx plus c. So this is the b that we're talking about here. Okay, with completing the square, the first example that I want to look at is one that has a leading coefficient of 1. So these are the easiest ones to try to solve using completing the square. So we'll start out with our original problem, and the first step is we want to take this 13 and move it over to the other side. Okay, so we'll just move that over. The next step we're going to go is we're going to actually factor out any leading coefficient, and I left this step in just because that would be the place you would do this at. But for this one, we have no leading coefficient, so we don't have to factor anything out from the left side right now. Notice I didn't say the greatest common factor. Okay, so it's not the greatest common factor, it's the leading coefficient. All right, so once we have it in this form, we want to figure out what we're going to add to both sides. So this is our b. So I'm going to take that b and I'm going to divide it by 2 and I'm going to square it, because if you remember we said we do b divided by 2 squared. Okay, so that's going to be 4 squared or 16 that gets added there. So we're going to add that to both sides. So we're adding this 16 to both sides. So here, this now becomes a perfect square trinomial, which means we can factor this. It factors to be x minus 4, and x minus 4, which we can write as x minus 4 squared. And then if we combine these together, then we have 3 for that. Now we are back to those type where we have a simple quadratic where we can take the square root of both sides. The square root and the square will cancel each other. We'll have plus or minus the square root of 3. We'll move the 4 over, and then we're left with our final answer. So it's more about remembering the steps than it is that it's a difficult process. Okay, here's an example of completing the square where we do have a leading coefficient. So here's our original problem. We have a leading coefficient of 3. So we are going to do this a little different. First thing we're going to do is move the 6 over. So it's a negative 6. And then we're going to factor out the leading coefficient. Again, it's the leading coefficient, not the greatest common factor. So take out that 3, and we're left with x squared minus 4x. So this is the part you're going to use when you're completing the square. You're not really going to worry about this 3. So this is going to be the b that we do, b divided by 2 squared. So we're going to have negative 4 divided by 2, and that's squared. So that's going to be 2 squared, or 4. So this is the 4 here that we are going to add in here. Okay. And normally we put the same thing on the opposite side because we have to keep it in balance. And I didn't really talk about that on the last example, but you put this, whatever you add to one side, you have to add to the other side so that you keep it in balance. This particular example here, though, we're adding a 4, and it's actually inside a parenthesis multiplied by the 3. So 3 times 4 is actually, we're actually adding a 12 to this side, and that's why we're going to come over here and do 3 times 4, or 12, on this side. So we have to keep it balanced. We don't want to do something that's going to throw it off balance. Whatever gets added to one side, we have to add to the other side. So here we've got 3, we've got this trinomial, and then we can simplify this down to just being a 6. This is going to factor. It'll factor, when we look at this, we're going to factor that x minus 2 and x minus 2 and x minus 2, because these should always be the same. If you've chosen this number right, these two parentheses are always going to match up and do some parentheses squared. So it'll be 3 times x minus 2 squared equals 6. We'll divide both sides by the 3 to get rid of that, and we get x minus 2 squared equals 2. Take the square root like we're used to doing, and the 2 and the square root cancel. And then you're going to move this negative 2 over so that you have 2 plus or minus the square root of 2. Okay, don't feel overwhelmed at this point because we are going to do a couple more examples. Okay, here's one that we're going to do by completing the square, and it does not have a leading coefficient. Okay, the first thing we want to do is move the 5 over. So we're going to have x squared plus 2x equals 5. There's no leading coefficient to have to factor out, so we're going to take our b, divide it by 2, and square it. So 2 divided by 2 squared is going to give me 1. So this is what we add to both sides. So we have x squared plus 2x plus 1. And we've got to do the same thing to the other side to keep it in balance. So we add 1 and we add 1 here. This is going to factor x plus 1 and x plus 1. And this is going to be 6. So this becomes x plus 1 squared equals 6. Take the square root of both sides. The square and the square root cancel, and we get plus or minus the square root of 6. Move the 1 over, and we have negative 1 plus or minus the square root of 6. Okay, on this next example, we're going to start out the exact same way. We're going to take this 1 over to the other side. So move it over here. We're going to factor out our leading coefficient. Okay, so this is going to be the b. So we're going to do b divided by 2 squared. So 4 divided by 2 and square that is going to give us 4. Okay, so that's what's going to get added in here. We have to decide what it is we put here. So I put a 4, but it's inside a parenthesis that's multiplied by 2. So I'm actually going to put 2 times 4 there. This will factor x plus 2 and x plus 2. That's going to equal negative 1 plus 8. So we're going to have 7. And we'll write that as x plus 2 squared. We want to divide this 2 away first. So I'll have x plus 2 squared equals 7/2. Take the square root of both sides. So x plus 2 equals plus or minus the square root . So we'll have plus or minus the square root of 7/2. Subtract 2. And we'll have negative 2 plus or minus the square root of 7/2. Okay, on this problem, we're going to follow the instructions of dealing with the ones that have a leading coefficient other than 1 here. So we're going to first move the 4 to the other side. Then we're going to factor out the leading coefficient, so that would be a negative 1. Then we want to decide what's going to go here that we add to both sides. So that's going to be the b divided by 2 squared. So that's going to be 3 squared or 9. We're going to put a 9 here. And over here, we're going to put negative 1 times 9 because we had the negative 1 here that's multiplied to the 9. So we'll do negative 1 times 9 there. Here, we want to factor this. And so when we factor this, we're going to have x minus 3 and x minus 3. We've still got the negative out in front. And then this is going to give us 4 and then a negative 9. So 4 plus a negative 9 will be a negative 5. We're going to rewrite this as x minus 3 squared. We want to get rid of this negative, so I'm going to divide both sides by negative 1. I'll have x minus 3 squared equals 5. From there, we'll take the square root of both sides. So x minus 3 equals plus or minus the square root of 5. Then our last step is to move the negative 3 over. So we'll have x equals 3 plus or minus the square root of 5. Moving on to our last method of solving quadratic equations, and that is using the quadratic formula. I will say that not everything is factorable. Not everything can be solved as those simple equations that we've talked about. And while everything can be solved using completing the squares, it can get very messy if you end up with a lot of fractions in there. But the quadratic formula is the one that's going to work for everything. So, so while you do need to know the other methods, this is the one that is kind of the backup that's going to work when you can't factor it and you can't do. It's not a good candidate for completing the square and so forth. So with quadratic formula, be sure it's in this form, ax squared plus bx plus c. And hopefully you have dealt with the quadratic formula before. You're just going to plug these values into the negative b plus or minus the square root of b squared minus 4ac over 2a. Simplify that, and that's going to give you your solutions. So sometimes it's going to ask for an exact answer. An exact answer is going to require that it be left with the radical, because the radical is going to preserve all the decimal places, even for an irrational number that where the decimals go on forever. It's going to preserve that just by keeping the radical there. If it asks for an approximation and tells you how many decimal places to round it to, then that's when you would actually put that in the calculator and get an answer and round it to the appropriate number of decimal places. But this would be an approximation. This would be an exact answer. Okay, so here we're going to look at finding the real solutions of each of these equations. So this is our A, our B, and our C. So we're going to do negative B plus or minus the square root of B squared minus 4 times A times C. And then all of that is over 2 times A. So be careful when you write it into this that you do keep track of the negatives with everything. So 2 negatives will make a positive. Plus or minus, sorry. Okay, so 5 plus or minus the square root of, this is going to be 25, and this will be 2 minuses make a plus, 12 over 2 times 3 is 6. So we'll end up with 5 plus or minus the square root of 37 over 6. You may be asked to write it as 5 over 6 plus or minus the square root of 37 over 6. So this and this would be equivalent to each other, and that's just splitting it up so that each part goes over the 6. If you could take anything out from underneath the radical, you definitely need to do that. 37 is prime, so nothing else is going to come from underneath that. Okay, if we look at this one here and we go through and do this one, we're going to have negative b plus or minus the square root of b squared minus 4 times a times c. All that is over 2 times a. So we'll have negative 12 plus or minus the square root of 0 over 8. So negative 12 over 8 is going to be, if we reduce this, 4 goes into 12 3 times, 4 goes into 8 2 times. So we actually only get one answer here. One thing I failed to mention on WebAssign, when you're entering these answers, it may want it as 5 6 plus the square root of 37 over 6, 7 over 6. So it may ask you to separate it out like that to give it as your answer, because it doesn't give you the option of the plus or minus. Okay, one last one here. We have negative b plus or minus the square root of b squared minus 4ac, and then that's going to be over 2 times a. So I have negative 2 plus or minus the square root of, that's going to be 4 minus 8 over 2. So we'll have negative 2 plus or minus the square root of negative 4 over 2. So for now, what we're going to have to say is no real solutions, because this negative here indicates we can't take the square root of a negative number. So any solution this would simplify to be would be a complex solution. And since we haven't looked at complex numbers at this point, we're only getting real solutions. This one would actually have no real solutions. What that means is if you were to graph this equation here, it means it doesn't actually touch the x-axis, and therefore we have no real solutions. Okay. And this is just talking about the square of any real number is non-negative, and therefore the square root of negative 1 would be undefined in the real number system, and so it would have no real solution. Okay, the part underneath the radical is called the discriminant, and this tells us how many solutions we would expect. So if we calculate this b squared minus 4ac part, you can see that if it's a positive, you're going to have 2 real solutions. If it's 0, you have 1 real solution, and if it's negative, you have no real solutions, which would mean you have 2 complex solutions. So if we look back at the 3 that we just got through working with, this one, the discriminant, would have been 37. So that would have been a positive discriminant. And here were our 2 solutions that we came up with, 2 real solutions. This one, the discriminant was 0. So we had 1 solution, and that 1 solution was negative 3/2. This one had a negative 4 as its discriminant, and it had no real solution. So you can see that that works out to exactly how this is here. Okay, here's some to practice on using the discriminant to determine how many real solutions each equation has. I'm going to give you a minute to work on this, and then you can check your answers. Okay, these are the answers that you should have gotten Remember that the discriminant is b squared minus 4ac, so that's what we're doing here for each one of these, doing the calculation and then determining the number of solutions. We've worked quite a few practice problems throughout this lecture. If you feel like you need additional practice problems, here are some that you may try to solve. Originally, I had said solve at least one using completing the square, but really none of these ended up being a great candidate for that. So just try to solve using the method that you deem to be the best method for that particular problem. You can advance this screen and check your work on these. Okay, the first one is just a linear equation, and this one you end up solving and get an answer of -3. The next one is a quadratic that can be factored, so if you factor that, you get -4 and -3. This one is a quadratic, but you need to first move the -12 over, so it's in ax squared plus bx plus c form. And then you can solve it using, I would recommend the quadratic formula for this one. And in simplifying it, you see that your discriminant is 0, and therefore the solution is 3 halves. This next one, it factors, but it factors using the, you would have to do the bottoms up method to get it factored. So you could also have chosen to do the quadratic formula. Either way, your solution should have been 3 and -1/2. Number 5 does not factor, and when you use the quadratic formula, you actually see there's no real solutions for this one. Number 6, again, would not factor, and this one you could use the quadratic formula. This radical cannot be simplified any further, so those would be the two solutions. And then on number 7, using the quadratic formula would be the recommendation there as well, and you end up with 4/3 and -5 halves.